Welcome back. This video is going to be tackling trace tables. In paper 2, the examiner will give you a piece of code written in OCR reference language, exam reference language, alongside an empty grid. Your job is to act as the computer's processor. You must read the code line by line and write down exactly how the variables change. I built this example on the screen that you can see. On the left, we have our codes, and on the right we have an empty trace table. Up in the corner we have our system memory. It shows what is actually inside the system memory, what the computer is actually holding in its brain. Before I continue, I need to warn you about a massive trap. Look at line 2. For x equals 1, 2, 3. In your practical lessons in Python, if you wrote Python loop using 1, 3, range 1, 3, 1, 3, it will stop before hitting the 3. But it would only loop for 1 and 2. In OCR exam reference language, the for loop is different. This is a common mistake students make in the exam. For the OCR reference language, you can see it's a reference. You can see next x, that's not part of Python. There's no range in the for loop. There's no open bracket, close bracket. We know this is a OCR reference language. It doesn't stop at 2. It actually runs to 3 and then stops. The 3 is inclusive. It will loop for 1, 2, and 3. Unlike Python, where it will stop before it even hits 3. If you use Python logic in exam trace table, you will miss an entire loop and lose marks. Always count the final number for OCR reference, exam reference language. Okay, so double check. It is OCR reference language. They will always give you OCR exam reference language for a trace table like this. So double check that. Okay, let's click on next step. The computer highlights line 1. So this, what's the memory? You can see total equals 0. And on our trace table, we write line 1, the total has changed to 0. Usually, initializing the variable, that would give you the 1 mark. On our table, we write line 1, 0. This is the start of our trace table. Okay, so click next step. And we can see for x equals 1, the variable x becomes 1. So you can see the line there, and we update our table line 2, x equals 1. And we don't do any outputs yet because there's no outputs so far. Outputs only for print. Let's do the next step. Total equals total plus x. So we can see total was 0 plus what's in x, which is 1. And we add it together, and total now becomes 1. Next step. X equals 1 to 3. Now we increment. Remember, it next x here as well adds 1. It adds 1 to x. X becomes 2. Total equals x total plus x. So currently total was 1 plus what's in x will equal to 3. And this is the different part of a OCR reference language. It will actually go to line 3, and total equals total plus x, because x has incremented to 3, and total plus total equals 6, 3 plus 3. And it will exit the loop, and we do print total, and whatever's in total gets printed there. So this is your trace table. The way it marks the trace table, it can be column by column, has all the columns been completed correctly, or it could be have the question mark scheme. Sometimes I've seen to have the initialized x and total has the output 1 mark. This column correct, this column correct. This could be a 5 marker. Okay, so the next thing we're going to look at is do until. So this doesn't exist in Python. It only exists in OCR reference language. and maybe some other languages, but slightly different. So when we click next step, currently count has nothing in it. Count becomes 0. We put that into our trace table. Do loop now is slightly different. It checks the condition at the end. Count equals count plus 2. So count becomes 2. So you add that on. Then print count. So here actually we notice that line 2 did nothing. You don't need to write line 2 in your exam. You could have skipped that. Or you can add it on. Both are acceptable. Print count. So the output, whatever was in count, it output it there. And then has count reached 6? Nope. So we do next step. Nothing. Count equals count plus 2. So add 2. Print count output. Has it reached 6? Nope. Count equals count plus 2. Print count. Now has it count reached 6? Yes, it has. And it exits the loop and we're done. That's our trace table done. Very simple. Do until logic. Remember, do logic always runs once and then checks the condition at the end. And that's do until trace table. While loops. This one again is very similar to Python. Only difference is it has an end while there, but that does nothing. In Python, you just need to come out the indentation. That's the only difference. Okay, so we're going to initialize the variable x equals 10. X currently holds a nothing. Now x equals 10, we write that into our line number 1. While x equals greater than 4, there's nothing happening in line 2. We can write line 2 here on our trace table, or we can leave it. We can skip that completely. X equals x minus 3. So what was in x? It was 10, and we minus 3 from it. Now it equals 7. So we add that to our trace table. Is it greater than 4 still? Yes, it is greater than 4. X is still greater than 4 because it's 7. We go back up, check. Yes, it is. We do nothing. X equals x minus 3. We follow along line 3. We add it to line number. And now x is 4. Is that greater than 4 anymore? No, it's not. It is equal. So we can exit. And we print out x. That will be the final mark. 1 mark there. So very same logic. We're just running the code in our heads and writing the outputs and any variable change. In the exam, they normally give you the column headings, line number, the variable names, and output. And filling it out correctly will give you the marks. And the lines where nothing changes, you can either write it on the tables or you can skip it. That's up to you. You may be asked to do a trace table where there's an array. I've seen a past paper question just like this, similar to this. So first thing, scores equals 0, 10, and 5. You could add that in the trace table, line 1. Sometimes the code is, the trace table is, the array is separate from the code. But if they do give the code inside the code that you need to make a trace table, you just add it like this, 10, 5. Total equals 0. And we look at for I equals 0 to 1. So I equals to 0. Add it to our table. Total equals total plus score I. So remember, when we're looking at an array, we need the square brackets and we need to see what's in location I. I is currently 0. So what's in location 0? 10. So arrays are normally 0 indexed. Okay. And it says total becomes whatever is in location 0. So total is 10. Now I becomes 1. We increment. Next, remember there's next I here. That's what it means, increment. Add whatever was in total, which is 10, and whatever is in location 1, which is 5. 10 plus 5 equals 15. Now we exit, print the total, done. Final one, selection if statements. So we've got score equals 0, for I equals 1 to 2, it will happen 2 times, 1 and 2, and we'll do an if statement. That's supposed to be 2 equals there, just looks a bit joint, there's 2 equals there. So score equals 0, initialization, line 1, I equals 1 this time, I equals 1. If I equals 1, does I equal to 1? Yes, it does. Then score equals score plus 5. We can see the score going up to 5 now, line 4. And then I becomes 2. It's no longer 1. It will skip the if statement and print the score out. As simple as that. So it is done an if statement, checking the values, follow along, and the last couple of exams has always been a trace table, so get familiar on writing and understanding OCR reference language. Very similar to Python, only one major difference you should spot is a for loop is inclusive, so 1 to 2, it does include the 2. Unlike Python, it will stop before the 2. Good luck.